everybody. Today we're going to start our second lesson in Unit 6, which is another way of measuring spread. So if you did that first lesson, you should have learned about finding the mean absolute deviation. So we're going to take that today and kind of extend it into what's called the standard deviation and the variance. So these are just more precise ways, or more, I guess, the ways that they use for research and things like that. Mean absolute deviation is kind of just something they used to introduce the idea of spread, but it doesn't really get used very often in the real world. So we'll talk about the two that get used way more often. But kind of the same idea as what mean absolute deviation was. So to start, we're going to look at this little problem here. It says your teacher has a problem and needs your input. She has to give one math award this year to a deserving student, but she can't make a decision. So here are the test grades for her two best students. So we're going to use their test grades and try to see, hey, who deserves this math award? So the natural thing to do is find the average, and then we're also going to find the median and the mode just to look at them. So let's look at Bryce. Let's find his average. So add them together and divide by how many there are. And y'all can do this while I'm doing it as well. So I got 720 when I added. And I need to divide that by 8. And that will give me a 90 average. Okay, so that's Bryce's mean. And then we need to find his median and his mode. So we need to put this in order to get our median. So 80, 81, 82, 90, 90, 98, 99, and 100. Okay, so let's find our middle value here. Okay, so it's between the 90 and the 90, so there's not really anything between that, so our median is 90. Or if you add those together and divide by 2, then you will get a median of 90. And then the mode is which one occurs the most. So he has two 90s, and we don't have 2 of anything else, so his mode is also 90. So mean, median, and mode are 90. And then let's do the same thing with Brianna. Okay, so average, we want to add these together and divide by how many there are. So again, I got 720, and then divide that by 8, and that gives me an average of 90. Okay, so they have the same average, and let's put hers in order. So her lowest grade's 89. So she has 2 89s, 4 90s, and then 2 91s. Okay, so our median again is between 90 and 90, so hers median is also 90. And then if you notice, we had 4 90s, which is more than any other number. So my mode is also 90. Okay, so their descriptive statistics are exactly the same. So that kind of leads you to the point where, hey, there's got to be something else that I can measure to see who did a better job or who was more consistent. And so that's what we're going to look at today. But I want you to read an answer number 2. I'm not going to give you my answer, but it says, based on your display, write down which of the 2 students should get the math award and discuss why they should be the one to see it or to receive it. So based on your numbers, who should get the math award? And if there's nothing different here, then maybe just kind of look back at their overall scores and see if you notice anything different about what their scores look like. Okay, and we'll come back to that. All right, so now what we're going to do is we're going to calculate the mean absolute deviation, the variance, and the standard deviation of Bryce's distribution. Standard deviation and variance are other measures of spread. Okay, just like mean absolute deviation, it's going to measure how far apart your numbers are. So standard deviation tells us on average how far each data point is from the mean. Okay, so basically the same definition as what mean absolute deviation was. We're just going to figure it out in a little bit different way. And you'll see I still put mean absolute deviation in the table, and variance is a little bit different. So we're going to use the table like we did before, just so you can see how to set this up. And again, there should be a point where you can skip this step right here, and eventually I'll have you skip finding the mean absolute deviation as well. So it kind of is up to you. But I went ahead and put all the scores for Bryce down. So we've got all those written down. And you'll see a lot of symbols here, but I'm just going to kind of explain what we're doing so that it makes sense, because there's a lot of different symbols in statistics, and if you throw them all out there, it makes it look really confusing. But we're going to start the same way with mean absolute deviation. We're going to take our data point, so this is representing my data point, and I'm going to subtract from the mean. That way I can see how far away they are from our mean. So these are Bryce's scores. So up here, we figured out our mean was 90. Okay, so we're going to take each data point and subtract 90 from it. Okay, so I'll write out the first one. So 90 minus 90 is 0. Okay, same number, so 90 minus 90 is 0. 80 minus 90 is negative 10. 100 minus 90 is positive 10. 99 minus 90 is 9. 81 minus 90 is negative 9. 98 minus 90 is 8. And 82 minus 90 is negative 8. Okay? And if you remember from the other day, if I were to add these together, it should always get me 0, because that mean is kind of your balancing point. So it's going to be equal above the mean as it is below the mean. Okay, so we really don't care about this total because it's not going to do anything for us. So there's two ways to make these numbers positive. The mean absolute deviation, this is what we talked about last time, is we can just take the absolute value of these numbers and hey, they're all positive then. So that's what's going to help us find our MAD. So just take the absolute value, which would make all of these positive. Okay, and then we can add those together. So 10 plus 10 plus 9 plus 9 plus 8 plus 8. That gives me 54, okay, which is going to help me find my MAD. So I would do 54 divided by 2, 3, 4, 8, which is 6.75. And the decimals are fine because it allows us to compare two different calculations. So these will definitely be decimals most of the time. Okay, so that's our mean absolute deviation. So our other way to work this out is called the variance. So instead of taking the absolute value of these numbers, you'll see that we are actually going to square these numbers, because that's another way to turn those numbers into positive values. So we're going to kind of ignore this column right here, go back to this column. Okay, we're going to take each of these numbers and we're going to square them. So 0 squared is 0. Okay, 0 squared is 0. Negative 10 squared is positive 100. Okay, remember squaring makes things positive. 10 squared is 100. 9 squared is 81. Negative 9 squared is 81. 8 squared is 64. And negative 8 squared is 64. So these numbers get a little bit bigger because we're squaring them. We're not just taking the absolute value. But once we get this, we're going to calculate it the same way. We're going to find the average of these numbers. So add them together. So 0 plus 0 plus 100 plus 100 plus 81 plus 81 plus 64 plus 64. So that gives me 490. And then I'm dividing that by 8 because I'm still averaging those numbers together. Okay, and that gives me 61.25, which is a pretty big number. Variance is always pretty big, so you'll see large numbers there. So the standard deviation is usually what we use to calculate. So to make this a little bit smaller or more accurate, to find the standard deviation, you take the square root of your variance. Okay, so the table is only going to let us get our mean absolute deviation and our variance. And then to get our actual standard deviation, we're going to take this number and take the square root of it. So square root of 61.25. And that gives me 7.8. Okay, so that tells you on average about how far apart they are from the mean, because his numbers were pretty spread out. And you can see your standard deviation is close to your MAD. That's kind of why we use the square root to get it pretty close to that number. But it's not going to be the exact same because we squared things instead of doing the absolute value. Okay, so what do these measures of spread tell you about Bryce's grades? So I'm going to use standard deviation to describe it. So it would say on average, his scores are about 7.8 away from the mean. Okay, so that's pretty spread out. He's not clustered around that mean. 7.8 would be like a 90 and almost a 98. So those are pretty spread out there. And what's nice about statistics is the sentences usually look the exact same. So if you can find the way to word it, just kind of word it that exact same way every single time to make sure you're consistent. Okay, so there's Bryce. So we're going to do the same thing with Brianna, excuse me, I'm giving her a nickname here. And then I'll just talk about some symbols and that's it. So I've already got the scores for Brianna. And remember, her mean was also 90. Okay, and that is something you'll have to find first, is make sure you have your mean. We just already calculated it. So we're going to take all of our data points and subtract our mean. Sorry, guys. Okay, so 90 minus 90 is 0. 90 minus 90 is 0. 91 minus 90 is 1. 89 minus 90 is negative 1. Go ahead and do these real quick. 91 minus 90, 89 minus 90, and then 90 minus 90. Those are both 0. So those are all real small numbers, so we've just got zeros here. Okay, so mean absolute deviation, we're going to take the absolute value of each of these. So just making them all positive. Okay, and then for our variance, we're squaring each of these. Okay, we'll still go back to this column. So 0 squared is 0, 0 squared is 0, 1 squared is 1. Okay, and those do happen to look the same because the absolute value of 1 is the same as 1 squared. Okay, so let's find our MAD. So we add these together, and that gives me 4. So 4 divided by 8 to average those, and that gives me 0.5. And then for our variance, add these together. That also gives me 4. So 4 divided by 8, because we have 8 numbers. Okay, and that also is 0.5. Okay, and then remember, to get the standard deviation, we take the square root of our variance. So square root of 0.5, and that gives me 0.71. I'll do to the 100th. Okay, so if you look at her numbers, okay, those are way smaller than what Bryce had. So Brianna's grades, it says, what do these measures of spread tell you about Brianna's grades? And we'll use the standard deviation. So on average, her scores are about 0.71 away from the mean. Okay, and when you looked at her original data set, you should have noticed that, yeah, her numbers are a lot closer together. They're more consistent. They're kind of clustered around that 90 average, where Bryce's were in the hundreds and in the 80s, so he was less consistent. So this just puts an actual number to prove that she is more consistent, and just instead of just saying it looks that way. Okay, so kind of the same thing we wrote with mean absolute deviation. The higher the standard deviation, it's going to be the less consistent they are. Okay, or we can say it has more variability, so they vary more. Okay, so there's two different ways to describe that. If it has a big standard deviation, you can say it's not consistent or more variable. Okay, the lower standard deviation, we're saying the more consistent it is, or it's less variability. Okay, her scores have less variability because they're all around the same value. Okay, so just use those calculations to find it, but you also need to be able to understand, which one's more consistent, which one's not, or even to be able to look at the data and say, this one's going to have a big standard deviation, or this one's going to have a small standard deviation. Okay, so the last thing down here is nothing really to do. I just wanted to show you these things. There are a lot of symbols in stats, like I showed you before or told you before, but it depends on what we're looking at. So today we kind of knew all of their scores, so we call that a population. Later we'll talk about what a sample is and how to measure things from a sample, but I just wanted you to see the symbols for them. So the mean, if it's a sample, we do this X with a bar over it. If it's a population, this is a Greek letter mu. So it kind of looks like an M there in cursive, but that's a Greek letter. So both of these represent mean. And then for standard deviation, you can use an S for a sample, or use this little Greek letter sigma. Okay, that's the lowercase sigma. Kind of looks like an O with the little curl on the top. Both of those mean standard deviation. Okay, notice mu starts with M. That's why it's mean. Sigma starts with S. That's why it's standard deviation. So it's just the Greek letter S and the Greek letter M. Okay, and then these are the formulas for variance and standard deviation. I didn't want to put those in the beginning because it kind of looks overwhelming. But the number of people in your sample, we describe that with an N. To find the mean, we add the numbers together and divide by how many there are. So this symbol right here, sigma, that means to sum or to add. So this is saying add all of your terms and divide by how many there are. Okay, so the variance, we subtract our data points from the mean and then we square them. We add them together and we divide by how many there are. And then the standard deviation, you can see they just took the square root of this value right here. Now, last year, I know some people had done standard deviation in psychology. And be careful because a lot of them, if I remember correctly, they were using samples. So they were dividing by n-1. Okay, right now we're doing the population. So you only want to divide by how many numbers we have. Like up here we had 8 numbers, so we divided by 8. Okay, we'll get into that later. But just make sure if you're in psychology, kind of separate that if y'all were working with samples there. Okay, so I hope this helped. Please let me know if you have any questions and I can help you out. You have a little practice that you're going to turn in on Shobi so I can see. You can either create a table in Google Docs or you can write it out. But please let me know if you have any questions, and I hope you guys have a great Easter, and I miss you.